Go ahead.
Hi, my name is Bernadette Wiggins, and this is my presentation on artificial intelligence and the human brain. Tonight we will be discussing the differences between humans and robots and how recent scientific research has shown that the day when we will coexist with humanoid robots, or robots with human characteristics, may be further off in the future than scientists may have thought. To begin, I would first like to introduce how the idea of artificial intelligence began. In the 19th century, a professor by the name of Charles Babbage had discovered a way to mechanize calculations which in the future would assist scientists in the problem that has racked their brains since the science hunt for algorithms of the human mind started. HAL 9000 became the first ever prototype of SAM, the self-aware machine, the first idea created that could think and plot like humans, much like the goal of that scientists are trying to make AI occur within the next 5 years. HAL 9000 paved the way to new ideas and attempted inventions of artificial intelligence like Roomba, the robot vacuum, that resembles today's compact disc players, and Aibo, the robotic pet/companion. The Roomba was supposed to ease housework for the average housewife, and the Aibo was meant as a toy to entertain the average 6-year-old. But as interesting as they are, they could not replace all the household electronic cleaning tools, or, most importantly, man's best friend. Now let us discuss the many differences that exist between humans and robots as they are now. Calculations are first on the list simply because this aspect of the invention seems to be the most difficult to come by. And here's why. Scientists have been trying desperately to come up with a precise algorithm or equation which would in the best way possible help scientists and researchers understand the complexities of the human brain enough to replicate into the brain of a machine, to be able to combine both the power of a computer and the intelligence of the human mind into one entity. The closest so far scientists have come to that is E=mc², Einstein's mathematical equation for understanding how the brain works and how the brain has been a product of evolution for over 500 million years. To understand how these equations come together and connect with the complexities of the mind, one would first have to comprehend how robots' brains or hard drives are programmed. We start with the basic cores and abilities that are built into a robot's system. These abilities and ideas are incorporated into the programs installed in a robot's hard drive, which manipulate how they think and act in a certain demeanor and ways they're expected to behave based upon Asimov's 3 laws of robotics. In comparing a robot to an infant child, you must imagine their brain as a clean slate awaiting instruction. An infant's brain works the same as it acts as a sponge, absorbing its observations based on the 5 senses: see, hear, smell, touch, taste. How a baby observes their surroundings is how they come to understand their world. A robot understands human existence through social and physical experiences. The feedback a robot receives are generated through how they behave in different situations. People react with a certain emotion in certain situations, but they understand where these emotions come from, whereas robots do not have the programming allowing them to do so. These 2 images give scientists an idea into the complex networking associated with the human mind. Each line connected to each box explains how our brains work. Think of the human brain as hooking up a stereo system to a DVD player and a TV. Each patch cord and wire connects to another electrical circuit, which when all connected together to various outlets, makes the whole system work. The neurons are the inlets or plugs that are fed through wires or synapses, strands of nerve endings that connect to different outlets in the brain. When every neuron and synapse is connected correctly, it allows the brain and body to function together. This is a comparison of a child's brain to a robot's brain, which is much different. You see that a robot's brain is mechanical and connects through electrical circuits. Going back briefly to our discussion on calculations, scientists would need enough processing power to produce powerful gamma rays in order to achieve the molecular level of the human brain. For a single brain, this is 10 to the 16th power per second, which would need to be expressed in nanometers. A robot's brain would need to generate 10 to the 18th per second. Is this even possible? Each 10 to 100 billion neurons connected to thousands of synapses would need to generate this kind of power in a robot's brain. This power is almost near impossible to achieve. The brain cells calculate the sum of information getting put into it and information being excreted out that is unneeded. A computer hard drive works much the same way, the only difference is the storage capacity. The mind of the human is able to store more information than a robot can. A robot brain can only store as much gigabytes as the memory in the hard drive will allow it to. Humans can store as much as is needed at a given time. The human brain exists with the memory to create reference points to help us understand our world and people in it, including understanding ourselves. Robots cannot create these references without a clear understanding of themselves and their world, and to do that requires creating a picture of their kind. They learn through experiences both physically and socially, as I said earlier, not emotionally, because they cannot feel, therefore they cannot comprehend emotions. They have 3 laws to abide by which dictate what they are and what they are capable of. Humans operate on Charles Darwin's natural selection laws in genetics. These 2 laws together form the person. They affect our feelings, our behaviors, thoughts, and how we perceive our surroundings. The only difference is robots have these laws built into them and they cannot be changed. Humans evolve and change in nature and in society in which we live. Humans learn to adapt, whereas robots may not. So to conclude my discussion, I'm going to leave you with some food for thought. In the coming years, a lot of changes technologically will occur medically and scientifically, maybe even militarily. But with all these changes, there's one thing to keep in mind: the power and capabilities of scientists creating a humanoid robot that can think, behave, and feel like a human is much further than we think. Review the differences in each of our minds, the complex calculations, the ability to come up with an algorithm for the mind, and basically ideas on evolution. Based on that, we will be seeing the day when cars fly before that happens. Think about it. Analyze it. Dream it. Do you think it's possible? Thank you.